All right, now we're live. In this video, we're going to solve a popular coding interview question: flattening a linked list. This is the problem statement. First, let me check whether I saw there is no viewers actually. Okay, one viewers I found here. Now, let's start solving this question. This is called flattening a linked list. This is the problem statement. While solving these questions, if you have an issue understanding or if you have any problem, you can post your question in the reply forum. All right. So in this problem, given a linked list of size n, where every node represents a sub-linked list and contains 2 pointers. It means that every node represents a sub-linked list and contains 2 pointers, next and bottom. Next pointer to the next node and bottom pointer points to linked list where this node is ahead. Each of the sub-linked list is in sorted order. We have to flatten the linked list such that all the nodes appear in a single level while maintaining the sorted order. Let's take a look at these examples. We're given this linked list. For every node we have, for this node we saw that we have next pointer. With the next pointer we can move to this node. With bottom pointer we can move to this node. And for this node there is no next node. Next is null. The bottom is this node, and so on. We have to flatten this linked list. We have to flatten this linked list from using the bottom. So first 5, then 7, then 8, then 10, then 20, then 30, and so on and so forth. Not 20 and 30 actually. 10, then 19, then 20, then 22, and so on. This is the problem statement. Now, let's see. Let me check it whether this live is working or not. All right, live here. Let me check it on my channel. Okay, I think it's working. All right, so let's get started with this problem. So we have here an examples. You can see that we have a linked list. We're given the root. This is the root. Okay, we're given the root. Now what we have to do, we have to flatten this linked list using a bottom pointer. For every node we have 2 parts: next, data, next, and bottom. With the bottom we can move to this bottom in this to this linked list, and with the next we can move to this node. We have to flatten this linked list something like this: first 5, then 7, then 8, then 10, 19, 20, 22, 28, and so on. So we have to flatten this linked list. This is not super difficult coding questions. This is a famous coding interview question. Now let's see how to solve this problem. I hope you've understood what is this flatten mean. Here actually we have 5. We have this node 5. Then we have to add this node 7 to the bottom, not to the next. Okay, we have to move to the bottom. The next will be null. All right, so we have to move to the bottom. I hope you have understood what I mean by this. So we have to just flatten it using this bottom linked list. So 5, 7, then 8, then 30, something like this. Actually we will have a 7, then 8, then we will have a 10. We have to maintain the sorted order. Now let's see how to solve this problem. First, let's talk about the brute force solution. Let me draw here the linked list. Okay, so let's draw here the linked list. First, the first node is 5. 5, then here we have 10, then we have 19, then we have here 28. So we have here this 4 node. Now let's move to the bottom side here, 7, then we have here 8, then 30, then we have here 20, the bottom of this 20, and then 19, 22, then we have 50. Just bear with me, this is not super difficult coding questions. This is I will explain these questions. And 40 and 45. All right, so we're given this linked list and we have access of this node 5. This is called root. I'm sorry, this is our root. Okay, now how we can solve this question? First thing what we can do, we can traverse the entire linked list, every single node, and we can store in a mean heap data structure. First we have 5, then we will store this entire linked list, then we will move to the next by the next pointer, then we will move to this node, and we'll just store everything in a mean heap using mean heap data structure. If we store every single node in the mean heap, we will have the lowest node, the node with lowest value will come first. So we can just add 5, then in the bottom of 5, then we have to pull from the mean heap, and then you can just add as bottom, and so on. In that way we can find out, we can flatten this linked list. But there is an efficient solution. This solution will take n log n time complexity, where n is the number of nodes we have in the given linked list. So how we can solve this problem? Let's see how to solve this problem efficiently. So first, what we're going to do, we're going to find out the last two. Actually, we're going to find out these two. Okay, we're going to find out these two nodes. We're going to merge these two. Okay, we're going to merge these two linked list. How we're going to do that? First, what we can do, we can declare here a pointer. We can declare here a pointer. Let's call it. We can declare any pointer. We can just move, check. Does the next of it null? No. So let's move here. Does the next of it is null? No. Let's move here. Does the next of it null? No. But the next of this is null. So we're gonna start merging this and this. So we're gonna merge these two. We know that how to merge two linked list using. We know how you can merge two sorted linked list. If you haven't solved the problem, merge two sorted list. The problem merge sorted list is the prerequisite for this video. Let me show you that. You don't have to solve that problem. If you haven't solved that problem yet, no problem. Let me show you. So if we have two linked lists, something like this, 1, 2, 7, and 4, 6, 8. If we have this kind of linked list, how we can find out how we can merge these two sorted list. So we'll use two pointer. P1 will point here, P2 will point here, and we'll create a dummy node. And here we'll take the minimum. So minimum is 1. Let's take here and let's move P1 to the next. What is minimum? 2. So let's take here. Let's move to the next. P1 will point here. Which is minimum? 4. So let's take here 4. Then P2 will point here. Which is minimum? 6. Let's take here 6. Then we have 7. Then when we have 7, P1 will point to the outer bound. When I see P1 points out of bound, we will just add here whatever value we have at P2.next, where P2 is pointing. So in this way, we can merge to sorted list pretty easily. Now, how we can merge these two these two linked list here. If you consider this is or linked list 1, this is linked list 2, then we can merge it. Let me show you how we can merge that. So this is going to be pretty straightforward actually. So this is our linked list 1, this is linked list 2. We'll use two pointer. Let's assume this is for our let's call in1 node 1, this is called node 2, or we can say p1 or p2, which is minimum. We'll create first here a dummy node, then at the bottom we'll take the minimum 19. Let's move this guy right here. So in1 will point here, which is minimum 22. Let's add 22 to the bottom. Then let's move in1 right here. What is minimum? n2. Let's add here n2. Let's move n2 right here. What is minimum? 35. So sorry, here we should have 28, then here 35. Now what is minimum of this two? 40, right? So 40. Let's move forward. So n2 will point here. What is minimum? 45. So let's add it 45. Now it will point out of bound. When n2 is pointing out of bound, we'll just add to the next the n1. So we are done. We are kind of done here. So here actually all right. So we have here n2 in1, yeah, so just 50. We're done. Actually we don't need here this dummy node. We can just take this first node as our, we can just take our first node here, this node 90 we can take. So at this point we have this linked list. We have just this linked list. Okay, we just merged it. Now what we can do, we can consider this is our second linked list and this is your first linked list. Okay, now we can merge that using similar rule. So first we'll have 10, then it is, let's call it n1 and n2. Now let's move here in n1 right here. So let's take here minimum is 19. Then in the bottom let's move here n2, minimum is n1. So let's take here 20. Now we see that n1 will points to null. If n1 is points to null, what we will do, we'll just add here to the bottom n2. If we add n2, it will be added this entire linked list. Then 35, 45 and 50. Okay, now we see that we have just two linked lists here. This 10 we will points to this. Now we see this, now we have this linked list. Okay, we have now this linked list. Now we can merge this two linked list using the same approach we just used. Now this is how we can solve this problem pretty easily. But the point is that how to find out the first linked list from the end and the last, how to find out every single pair of linked list. We can do that using recursion pretty easily. We will show you when we'll write our code. Now let me check some comment if you guys are commenting on this video. If you have any question, you can comment. I will try to answer. There is no comment actually. If there is any comment, I will try to answer. If you have any question, post your question right here. Do you have any question? I see there is no question actually. Since there is no question, so I can just move forward. So now let me all right, now let me show you the code for this problem and how to find out the pair of linked list from the end and how to merge them. Now let's move to the code, and this solution is the efficient solution of this problem. Let's write out the code now. All right, let me check here viewers, just one views here. I'm sorry, no problem. I think the views will increase day by days. Anyway, now let's write out the code for this solution. All right, so this is Geeks for Geek site. Here let's write out the code. first thing, all right, so first here what we're going to do, we're going to check if root equals to null, if root equals to null, or if root dot next equals to null. We'll call a function recursively. If we saw root equals to null, it means we're given the root is null, given node is null. And if the root dot next is null, for recursive call, we'll check it, we'll just return the root. So for basically it will return the last node in our we find it by just moving by next pointer. Now here what I'm going to do, I'm going to say root dot next equals to flatten. I'm going to call this function recursively to find out a pair. So root dot next, it will we will find out a pair. Root will be our first linked list and root dot next will be our the last or the second of our pair. Now here I have to call a function merge to sorted list, merge to sorted list. This is exactly similar to the merge to sorted list problem exists on LeetCode. I can show you this problem here. Merge to sorted list, LeetCode. All right, this problem. This is going to be similar to this merge to sorted list here. Now let's write out here code. We'll have first up our pair or root, and then second one is root dot next. It will return the head of the merged linked list. So we'll just return that, and that will be our flattened linked list. Now let's implement this function right below here. So merge to sorted list. Right here, node return type is node merge to sorted list. Let's call it node, let's call it in1 node into. Okay, you can see the class in every single node we have data, next, and bottom. All right, now let's create here a dummy head. So let's create here dummy head. Let's call it new head equals to new node with 0. We can use any value, it doesn't matter. And this will store, this will be the this node will add our sorted linked list to the next of head. So we can just return here new head dot bottom, actually new head dot bottom. We have here bottom and next and data. All right, so let's complete this code here. Now let's write out code in between here, and let's create here a temp pointer. So node temp will point to our new head. This is temporary temp pointer just for adding our current node values to keep track the value over which we should add our current node. Now here we have to check while in1 is not equals to null, as well as into is not equals to null. While in1 and into is not equals to null, what I'm going to do, I'm going to check the value. If in1 dot data, if in1 dot data is less than into dot data, we can use your equals, no problem, let's use your equal. And or we can just handle that by else statement. We'll say that, no worry. Now here what I'm gonna do is that we have this in1 is less than if this condition is true. So temp dot bottom equals to in1, right? Now we have to move temp to the bottom. Temp equals to temp dot bottom. Okay, this is our first step. Also we have to move our in1 to the bottom. So in1 equals to in1 dot bottom. Okay, because our node 1, we just accessed our current node 1, so we have to move our node 1 to the bottom. Else if this is not true, then what I'm going to do, I'm going to just copy this code from here. Let's copy it. and let's just change this to 2, and here 2, here 2 as well. Yeah, this is your algorithms actually, and this algorithm will be efficient for merge to sorted list. The time complexity of this algorithm is linear. O of it will take O of n time complexity, and the space complexity is constant, but for our recursive call, it will takes the complexity. We consider if we consider this is the width, then it will takes space complexity for the recursion call stack at W. If we do not include recursion call stack in our complexity analysis, then time complexity would be space complexity would be constant. All right, let's run this. This is for space complexity SC. Let's compile this and run. Let's check it if our code is okay. If we saw anything goes wrong, we'll fix that. All right, we have some problem here. It says that merge to sorted list, root and root next cannot find symbol merge to sorted list class GFG. I'm sorry, what's going on here? Merge to sorted list. Oh, we might have here a typo. All right, I think it's okay. Let's run this and compile. Still okay, no problem, it's okay. Now we see expected output 5, 7, 8, 10, 19, 20, 28. I think nothing goes wrong. If everything is okay, let's submit it. All right, we have some problem here. Let me check what's going on. We have temp to bottom, equals to n to here, and oh, I'm sorry, I'm so sorry here. I'm so sorry, guys. I'm so sorry about it. Once n1 or n2 points to null, we have to check that. If n1 equals to null, we have to say temp dot bottom equals to n2. In that case, n2 is not null. If n2 equals to null, what do you have to do here? Temp dot bottom n1. This is our simple check. All right, now let's let's compile and run it. I think it should work now. I'm so sorry, guys, about that. I just forgot about the issue for the case it might be happen. I think it will pass all the test cases. All right, it passed all the test cases. This is the solution to this problem. This is so simple, actually. This is not a difficult question at all. I think so. So we just solved these questions. Today we goes live 3 times on the channel. And if you want more video like this, guys, if you want any specific coding videos on the channel, just let me know. I'll try to record that video for you. And if you have any question, you can ask your question in the replay forum. I'll be glad to help. Yeah, anyway, this is the solution to this problem, flattening a linked list. Alright, guys, thanks for watching and thanks for joining in. See you. Till then, take care.